Good morning, everybody. My name is Sebastian Schneider. I am the responsible product manager for the 7VU85. Yeah, the first slide about the Zipotec 5 7VU85 high-speed busbar transfer shows you the advantages of the platform and of the application. So that means the high-speed busbar transfer function is now implemented on a Zipotec 5 platform. So this functionality provides multi-breaker application with up to 20 breakers. We have a flexible load shedding functionality, which is used to shed the load on the motor bus before the switching and afterwards, if it is necessary. We have an ultra-fast transfer time with the fast mode for up to 10 milliseconds. We can add protection functions. And on the other hand, we have the modular design and customized configuration support. This reduced, of course, the wiring because we need only one device instead of multiple devices. We have the simultaneous, sequential and parallel switching in the device. We have different switching modes available, like fast mode, real-time fast mode, synchronous mode, or residual voltage mode. And of course, as you know from the other devices, we have always predefined application templates, which can use to start your application, your engineering. And in the end, you can also instance protection function, frequency functions from the 65 library. If we have a look on the advantages of our HSBT system, you see we are faster, easier and more reliable than before. So faster means we provide a fast transfer across the whole factory or across the whole process. We have a higher success rate by achieving the real-time fast mode to transfer from one infeed to the other infeed. We have also high-speed contacts, which reduced as well the whole chain of the closing of the breaker closing. Easier means we have easy engineering, so that means there is no additional needs for having external relays to connect the right voltage and so on. We have a fault detection implemented, and we have one device for various applications. And more reliable, of course, we are using the Zipotec 5 platform, which the hardware and also the software is designed for. And then we have the fast transfer, which is compliant with the NZ C5041. And all these advantages leads to a very reliable product. So do we have a closer look in which typical areas or which typical applications we need to use a high-speed busbar transfer system? For example, in power plants, petrochemical industries, pharmaceutical industry, hospitals, data center, or semiconductor manufacturing. You can imagine in all these kind of applications we need a continuous power supply, an uninterrupted power supply. Especially when we think about nuclear power plants, it must, at any time, we need to supply the voltage or the power for the cooling pumps. This is also a safety reason. And if we have a look here and we talk about fast transfer, fast algorithm, then we see here we have the different types of simultaneous or sequential modes or the parallel mode. And in all these different switching types like fast mode, real-time fast mode, in-phase mode, and residual or long-time mode, we can enable these modes to the different sequences. And when we talk about fast, then we always talk about fast mode, real-time fast mode, and in-phase mode. And then we have the so-called backup transfer functionalities, which is the residual mode and the long-time mode. Here we talk about seconds instead of milliseconds. And of course, the device is doing the switching automatically. So that means they automatically calculated which kind of switching modes the device is using and decided by himself. So when we have a look to the functionality, to the HSBT, high-speed busbar transfer functionality, you see the functionality have different tasks. One of the tasks is the reliability check of ready and unreadiness. That means if this transfer is ready or not. We have the multiple sensitive start types like electrical fault start, non-electrical fault start. We have the CB invert and open start, for example. We have an undervoltage start criteria, the frequency, under frequency start criteria. We have a manual start condition, which is normally used after clearing the fault to switch back to the main infeed. We have additional start criteria or additional start types, for example, for the simultaneous and the sequential. And you can use that additional start types as well to combine it with an reverse power protection, for example. Then we have one block which is responsible for the block-in logic, for example. Then we have the settable transfer sequence, sequential, simultaneous, parallel. And last but not least, the algorithm himself, which is implemented the fast mode, real-time fast mode, in-phase mode, and so on. So, come we to the next slide. And this slide shows the benefits of the whole system. That means we have a new generation for high-speed busbar transfer system. This ensures the uninterrupted power supply with different transfer modes. Due to that, we have a great cost-saving potential with new features and only one single device instead of multiple devices. And of course, the functionality prevents motors for large impact current and large impact torque during the transfer. Then the better performance compared to the 7VU6. We have an ultra-fast switching time on up to 10 milliseconds for the sequential transfer. We have the CPOTEC 5 architecture, which offers the full flexibility in hard and software, and that means the device is expandable, and you can select your device if you want to, or you can make it possible that it fits to your application. And of course, this device supports up to 20 circuit breaker. And then, as I told to you before, that we have the predefined application templates available. Now with the version 9.60, we have now up to 5 new application templates available in Dixie. So that means one unified platform. So that means the HSBT functionality, the application, is based on the well-known CPOTEC 5 platform. There are reliability, the stability, and also the efficiency is guaranteed. So, and of course, with Dixie 5, you can have an easy configuration in case of complex applications and scenarios. This will be shown later during my presentation. And of course, due to the platform of CPOTEC 5, the design is future-proofed. That means we have always the latest cybersecurity fixes. We have the latest version of the hardware and the devices as well. Process bus ready. That means we can also use the HSBT functionality in a digital substation with process bus. Now we come to the concept. This is how the concept is working of the HSBT system. So that means here on the left side, we have a typical application in an industry. So we have a 5 breaker application, 4 incomers, 1 tie CB, and to provide here the HSBT functionality, we need up to 6 devices to have the transfer from one side to the other side. So you see also there's a disadvantage. That means we need some interlockings, we need some blocking conditions between each devices. We need external wiring. And on the left side, on the right side now, you see there is one dedicated device, one function group HSBT, which contains the different transfer directions. And everything, the same application, can be covered in one single device. So how does this works? Here on the left side, we see the application. This is I feel, most common application in the field. We have 2 incomers and 1 TIE-CB. And this is also the application what we want to show today during the dynamic testing. And due to the application, we can count up to 6 transfer directions. And you can set these transfer directions here in Dixie by adding new functions called transfer direction, and then you can say, okay, you want to transfer from in comma 1 to in comma 2, from in comma 1 to busbar 2, and so on and so on. And each transfer direction can be added separately and can define separately if it is an automatic transfer direction or a manual transfer direction.